Hello, Trig friends. This video is from page 13 of your Trig notebook. These are the couple little problems that we didn't get to in class, which is using right triangle trig to find a side of a triangle. So this is something you probably have seen before if you've ever seen SOHCAHTOA. If you've ever seen sine, cosine, and tangent before, this is probably what you did with it. But I wanted to make sure we had a couple examples of these so that when you do your ALEKS and such, you know what you're doing. So in the first one, notice that we are actually over here in letter A. We did do these last three problems quickly at the end of class. But our triangle for A and B, and for most of these problems, they would be in degrees. So we need to change our calculator back to degrees. So don't forget to do that. And remember to do that, you go to mode, which is at the top of your calculator. One of those top couple buttons, and then press mode, and then your choices are radians or degrees. So just change it to degrees so that the problem will work. And let me pull this down a little bit. And so what we're going to do is take a look at our triangle and kind of determine, are we going to use sine, cosine, or tangent for each problem? So we have 22 degrees given, and as you can see, the side that is labeled X is actually opposite of the 22-degree angle. And then the side 18 is the adjacent side. Remember that the unlabeled side here, that would be the hypotenuse because it's opposite the right angle. All right, so opposite and adjacent are the ones that we're talking about. The one we want to know is X. The one we already know is 18, and that's adjacent. So opposite and adjacent go with tangent. So we're going to set up a little tangent equation. We're going to say the tangent of the angle, so tangent of 22 degrees, is equal to the opposite side, that's X, over the adjacent side, that's 18 feet. Okay? And then you're always going to get a little equation that looks like this. You're going to have a trig function with an angle, and then the two sides as a ratio. Okay? So hopefully that all kind of comes together well. Then we just solve this equation for our unknown. So our unknown right now is x. X is divided by 18, so to solve, we're going to multiply each side by 18. So we say that way these will cancel. So you'd have x is equal to 18 times tangent 22. So this is where 18 tan 22 degrees would be typed into your calculator, and you're going to get a decimal answer. Again, make sure you're in degrees. When I typed that in, I got about 7.27. And then remember, our answer would be in the same units as the original triangle, which would be feet. So 7.27 feet, because it says round to 2 decimal places. Sorry, I don't have a calculator emulator on my own computer, so hopefully typing that in is pretty straightforward for you. All right, second problem. Now everything's kind of rotated around, but that doesn't change much. You see that we have the right angle there, so opposite the right angle, that is the hypotenuse. So the hypotenuse is our y, and 78 is our angle that we're given, and then that side 10 would be opposite of it. Okay, this side that is not labeled, that's our adjacent side. So the two that we know about are the opposite and the hypotenuse. Opposite over hypotenuse is sine. So our equation this time will be sine of 78 degrees. Okay, so the sine of the angle we know is equal to opposite, that's 10 inches, over hypotenuse. So notice that I don't always just put the variable on the top. It would be more convenient, but I don't. I always use the ratio, SOH. Opposite over hypotenuse is sine. All right, so now to solve this one just takes a little tiny bit more algebra. So, we need y, but we don't want it on the bottom there. So we're going to actually multiply both sides by y. So when we multiply both sides by y, we get 10 is equal to y times the sine of 78 degrees. Okay? And now, second step then, we need y by itself. So y is times sine 78. So we will divide both sides by sine of 78 degrees. You will end up doing these two types of problems a lot, so you'll kind of see the pattern of how to solve them by doing them multiple times. So we are going to divide by sine 78. So our y is equal to 10 divided by sine of 78 degrees. When you type that in your calculator, you should end up with about 10.22, and this problem was in inches. So I'm going to make that as inches as my answer. One thing you might want to just double check when you find your answer is if you have the hypotenuse, you can compare it. The hypotenuse always has to be the longest side. So although it is only 10.22, that's okay. It is longer than 10, so we should be good there. All right, hopefully that is something you've seen before and, just a good refresher on that. And these next two problems are applications of the same thing that we were just doing. So we'll do both of these as well. And again, I'm going to guess that you have also probably seen this type of problem before as well. So these are called angle of elevation or angle of depression problems. And again, we're going to draw a little triangle and we're going to use sine, cosine, or tangent to solve them. So it says to find the height of a flagpole, Fred measures a distance of 100 feet from the base of a flagpole. Okay, so we have a flagpole. Yep, got a flag on it. And that is 100 feet from Fred. Here's Fred. Oh, okay. So I was about to draw Fred. I guess I'll just draw him here. That's fine. Fred, standing right there. He uses a sextant, which is a simple angle measuring tool, to measure the angle of elevation to the top of the flagpole. Okay, so if Fred is approximately 6 feet tall, notice they're giving us Fred's height in feet, 6 feet. How tall, and that he measures the angle is 51 degrees. So angle of elevation, you're going to look horizontally, just like you normally look, and then you elevate means to look at up. So you're going to look up to the top of the flagpole, and this angle that he measured was 51 degrees. Okay, so the triangle that we made is actually up in the air because of Fred's height of 6 feet. So the triangle that we're going to use for trig is right here. And then we know though, because this would make like a little rectangle, this would be 100 feet still. And the thing that we're going to find from the triangle is x. And then I think when we find x, then we're going to add his height, the 6 feet, to it to find the total height of the flagpole. Okay, so hopefully, drawing a nice little picture with the situation is very helpful. Okay, so let's see. We have the angle of 51 degrees, and as you can see, x there is the opposite side, and the 100 feet is the adjacent side. Notice I don't actually care about the hypotenuse because it doesn't have any information on it, right? We don't know anything about that. So we're going to use opposite over adjacent or tangent. So we're going to go the tangent of the angle, so tan 51 degrees is equal to opposite over adjacent, x over 100. All right, this is a case where the 100 is on the bottom. We need to multiply both sides by 100. And then we will get x by itself is equal to 100 tan 51 degrees. And when I type that into my calculator, I got 123.49, and then this was in feet. Okay, so to find the height of the flagpole, again, we're going to add the 6 feet of Fred, and that would be 129.49 feet. Okay, it doesn't say what to round to, so we'll just continue with our 2 decimal places. Okay, and then finally, angle of depression. So angle of depression can trick people a bit. So definitely take note of how this one is set up. Okay, so when Juno is visiting Chicago, she goes to the top of the Willis Tower. It used to be called the Sears Tower. Now it's called the Willis Tower. So anyway, it's a big skyscraper in Chicago, and it's got like little things at the top of it and stuff. Okay, and the elevation of the tower is 1,451 feet. And she looks down at the bean, which is technically called the Cloud Gate sculpture, but it's this cool sculpture. It's shiny. It's like a shiny big old bean in a park. And it says, if the angle of depression between Juno and the bean is 15 degrees, approximately how far is the Willis Tower from the bean? So here's Juno at the top of the tower. Notice they don't tell her height. They don't want us to include that. It's probably not a difference maker. But Juno is looking out, and then what she does is she looks down at the bean, right? Angle of depression means you're looking down. And so this is 15 degrees. It is not here. So the common mistake is to, there was already a line here, and then there's a line from the top of the tower to the bean. And so people put the angle here. But it is not, that's not 15 degrees. Okay, it's not that one. It is this one because she needs to look from horizontal to down. Another way to look at this is if we're gonna be finding how far it is from the bean to the base of the tower. So in other words, this is x. So another way to look at it is if this is 15 degrees, and it's the angle of depression, the angle of elevation is 15 degrees as well. Imagine if someone was at the bean looking up at the top of the Willis Tower, that would be the same situation. Okay, so some people find it a little easier to use like this triangle instead of the triangle that's all in the air. Okay, so that's what we're going to do because we already have 1,451 feet as one side of the triangle. The tower better make a right angle. We're not the Leaning Tower of Pisa, right? So use that. So the triangle we're using actually, even though it's set angle of depression, we're going to flip it over and make the angle of elevation triangle. All right, so there's our triangle. Now let's take a look and see. We have 15 degrees, and the 1451 is the opposite side from that, and the unknown side is the adjacent side. So once again, we're using tangent. So that would be the tangent of 15 degrees is equal to 1,451 opposite over adjacent. So this time again, we got the x on the bottom. I will say most of the angle of elevation and depression problems tend to be tangent. And I think that's just because the diagonal line that would be the hypotenuse is usually not known, right? Usually the things that we are talking about are horizontal or vertical. So it tends to be tangent. It doesn't have to be, but it tends to be. All right, in any way, to solve, we're going to need to multiply both sides by x. So when we do that, we get 1451 is equal to x tan 15. And then we're going to solve for x. So divide both sides by the tangent of 15 degrees. Okay, so x is equal to 1,451 divided by tan 15 degrees. And when I type that into my calculator, I got 5,415.21 feet. By the way, I did kind of make this problem up myself, and I checked, and the bean and the Sears Tower or Willis Tower are about a mile apart. So that's why I kind of got those numbers. So it's pretty accurate. Anyway, I hope this is helpful and that you have nice examples now of for this page. Have a great weekend and do your homework and stay warm. Bye.